Hey guys, Yusuf here, back with another video. Fooling around with Houdini again. This time I want to show you how I created this logo animation. Nice. Now that you saw the logo animation, let's get into how I created it. Real quick, let's jump into Houdini. I created the animation using sort of 3 stages. I started by creating the moon, okay, which is essentially half a moon. And then we created the sand effect, 2 seconds to load. And then we created a proxy moon, which assists with having something renderable in DaVinci Resolve. I used Houdini and then I moved everything into DaVinci Resolve, and I'll show you how I did both steps. Let's start with the moon. Okay, before we get into the logo animation, let's take a quick peek at my logo. Over here we have an image which is basically the text and the icon, and at the moment the logo is a circle with some cutouts for representing craters, as well as some craters on the surface. So we need to make sure that those craters are available. So what I have done is I created a sphere and I increased its frequency a little bit to make it a little bit more high poly, and then I clipped it. The clip basically allows me to delete everything from on one side of the clip, and the reason I'm clipping it is because whenever I try to create this effect with the full moon, it's too heavy for my PC. Houdini crashes a lot, so I clipped it, effectively cutting the effect in half and making sure that it's only affecting one side of the moon. I polyfill it to fill that hole, and then we start going into the node tree. Now the first step is I want to manually place, basically I want to create the craters, right? And I'm using a technique that I learned to create these craters, to create the entire moon. I'm using a technique I learned from one of my Houdini courses. It's a paid course. It's, I think, from the VFX school, the Houdini Renaissance program. It's a pretty easy effect. I used pretty much the same technique, not really changing much. I just made it a little neater to create the craters. So basically what we're trying to do is we're trying to create the craters, and we use SDFs in this section here. So we have this half moon, so we have the base shape. The first thing I want to do is I want to manually place some craters that fit the logo shape. So what I'm doing is I create a new sphere, and then I position it, like I transform, I scale, and I position it where I want. So if we were to template the original and positioning the moon or the craters, which is basically a sphere, in sections of the moon. So you can see here I position each one separately, and then I merge all these positions, and you can see here that I roughly have shape: the large crater, smaller crater, and the crater cut out on the side and the other side. And that creates this manual placement. In addition to manual placements, I also want lots of small craters all over the place, because these craters aren't the only craters. These are the hero craters, but then we also need like other craters randomly placed all over. So to do that, I create a new path, and I take this, first of all I add normals, point normals, okay, and then I group it. And what I'm grouping is basically I'm taking my manually placed objects, I slightly scale them a bit, and then I group based on an object. So you can see I'm using a bounding object. I change this to points, and I group these points. The reason why I'm grouping these points is because I don't want any scattering to happen in these areas. Okay, so now you can immediately see there's some problems here. This one is not getting detected properly. I think it's because we're scaling too much. It's alright, we can adjust it. Okay, and we get this kind of effect. Okay, and then what I do is I'm promoted this group from points to primitives, so I can get a primitive group, and I invert it. So basically I am inverting the group. So instead of selecting these areas, I select everything else. So that's just a handy node. Okay, and then what I do is I create the scattering. So what I've done is I've used 3 different types of scatter: big, medium, small. So I use a p-scale, take those at every point around, and I scatter based on this group. You can see here I'm scattering points based on the group. Okay, and I'm also using this p-scale okay, oh, this is the wrong place, okay, to adjust the p scale of each scattered point, and this will allow us to have an effect like this. You know, it will scatter these spheres and copy it all over the place. These spheres, by the way, are the radius and frequency of which is adjusted here, and they just scatter. It's not so important, the detailing here. It's just, we just need some spheres scattered all over. And we do the same thing for the medium section. I think this one also has a bit of a confusion here. This should be this one. Okay, we have these spheres, and we have these ones. So it's basically the same thing. All I'm doing is I'm just changing the p scale value. I'm changing the custom ramp here. I'm p scaling based on a custom ramp because I want more of a certain size and less of a certain size, which is a bit more realistic. And then we scatter this, and then we merge everything together, okay, and we create this. So we have our, and when we're merging, we're also merging the manually placed ones plus all these small ones, and this creates this kind of shape, these spheres, which will essentially be the crater. Now what we're doing is I have a subnet here which will take this as an input as well as this as an input. It's doing some fancy work over here, and it's essentially creating this effect. So what's going on? Let's take a look. Okay, let's go in. First of all, here we have the input 1, which is basically this object, and input 2, which is the craters. Cool. Okay, and we can visualize this if I put a null node here. All right, cool. So what I'm doing now is I'm converting everything into a VDB. Okay, I'm using a node called VDB from polygons, and I'm converting it at a pretty low voxel size, and I'm also converting on the other side these objects as well. And then what I'm doing, okay, if I'm taking this, what I'm doing is I'm using this input. I'm using something called a voxel, a VDB combined node, where we just change the operation. We can copy SDF union, intersect, difference. This is kind of like a boolean for VDBs. I'm using a SDF intersection, so I'm trying to find out the intersecting elements. And if you look at this, this is like the crater shape. Intersection between this and this creates this, and it gives me the sort of the crater shapes. And then what I use is something called a reshape, which basically allows me to inflate these crater shapes a little bit, just dilate it, inflate it. And then what I do is I do something called SDF difference. So I'm just taking the original sphere and the inflated intersection sphere, and then I'm just saying subtract the original sphere from the intersection, and I get this type of shape. So what is this? This is basically the crater itself. Wonderful. Now the next step is to create is to combine it with the original. So what I do is over here I take a difference again, and I take the original input and I subtract the spheres from this, and I create sort of the craters, but it doesn't quite look like craters per se. And what I do is, and this is a technique I learned from the course, pretty much copy pasted, take this and I combine it with this, creating this sort of rim. You know, this rim is basically the sort of the crater shape. And then I use a VDB smooth to just smooth it out because it's a little rough here. I smooth it out, and this gives the crater shapes much better. Okay, and if you notice, you might see that there's the big, small, smaller, the cutout here, the cutout here, which is roughly how the logo was structured. And we output this, and that's it. And that pretty much creates this crater effect. And then what I do is I cache it. I cache the entire VDB because I want to make sure that I'm not recalculating this every time. This is a pretty heavy calculation, so I just cache it by saving to disk, and we save it. Nice. Then what I do is I use a node called convert VDB, and I convert everything back into polygons, and this means we can manipulate it as a polygon. Now I add a mountain node, okay, and the mountain node basically adds this roughness to it. Now if I really want to improve this, what I would do is I would add multiple mountains. Like I would add mountain big, mountain small. To be honest, I'm not going to do that right now. I just feel like this is good enough for now. Maybe I might improve this further. By adding the mountain, I'm just disrupting the shape just slightly so that it looks a little more like rocks than, or rather uneven like terrain, than very smooth like it was over here. Okay, and this gives it a little bit more of a moon shape. And then what I've done is I cached this out. So this was the original, which I cached out. I'm not gonna recache it. Okay, if I save to disk, I'll save the new one. Okay, so we have to change it. So this was what we had originally. Okay, and it essentially creates the shapes that we're looking for, and I like this a lot better than the previous. Okay, and what I've done now is I create an out a null node, which is just the out moon geo, and that's the moon. Okay, then what I did was I hid this and we moved to the sand stage. Okay, in the sand moon, let's go in. What I do is I object merge the original moon geo. Okay, I just merge this in. I use something called vellum grain constraint. So, and basically what I'm doing here is I'm creating grains. If I just zoom in, you'll see that there's just little spheres throughout the object. Okay, and creating these little spheres, and it's based on the particle size. Okay, so I can just adjust the particle size, and if I keep decreasing this, the particles will get smaller and smaller and smaller. But I really want to be careful with this because there's already 12 million particles here, so it's pretty crazy. I don't want to decrease it more than this. I also enable this jitter scale, which jitters the particles about, making them a little bit more random and not so even. And then I apply a null node here just to make sure that I have a reference to this. I call this initialization of the moon grains. And then I add this attribute noise, which I'll show you what it looks like. The attribute noise is basically creating noise for a parameter called attraction weight, an attribute called attraction weight, and this is kind of creating this is specifically for the grains simulation. Basically, wherever it's darkly colored or brightly colored, it's basically going to have a strong attraction weight, and wherever it's blue, it's going to have a weak attraction. That means that those are the areas that's going to crack easily. And I also have this attribute create, which creates a stopped attribute, and the stopped attribute is another attribute used by vellum grains, which basically means if stopped is equal to 1, the vellum grains will not simulate, and if stopped is equal to 0, it will simulate. So you can stop and start the simulation this way on an individual grain basis. So that's really helpful. It has to be a point attribute, and it has to be an integer. I use another attribute called a point warp, a point warp to adjust another attribute, which is basically the stop. Let's visualize the stop for a second. Again, this is helpful for the destruction that starts from this side and moves to that side. So basically here I'm using a setup like this. So I take the relative bounding box of input 1, which is basically this original object, and I take the position, and we can create the relative bounding box. So you have this bounding box data. You can split this into a vector, like 3 floats, and I take the z parameter, which is basically this direction, the z direction, and I'm comparing to see whether the z is greater than another input which we're going to animate. Okay, so this is the input we're going to animate, and I'm also multiplying this by a noise so that I could get a little bit more distortion in the animation. And then what we're doing is we're going to output this. We are binding it to this stopped attribute so that it keeps updating the stopped attribute. Okay, and we'll go beyond 45, and you start to see, okay, its point warp is changing and it's being multiplied by the noise, so it's not a perfectly straight line. And as you go further, it changes some more, and as you go much further, it really pretty much almost completely destroys the model. Cool. So basically what's happening here is that as time goes by, I'm animating this input value, which is continuously increasing. So the z value is continuously less than this value. So the stop value is changing from 1 to 0 as we go through this. So all of the darker spaces are where the stop value is 0, and the lighter spaces are where stop value is 1. And this basically creates an animation so that we can start and stop the simulation of the grains. We just drop a null just so that we can get this output. And then this is where we drop our simulation, and if I click on this, we'll see the simulation. I don't want to do that because if I click on this, it'll start to simulate, and there's quite a lot of grains here. So let's just, for the demonstration purposes, reduce the number of grains so that we can see this in real time. And if we go now to the simulation, go in, and you can see here what I'm doing here, and inside the simulation what's happening is I'm doing two things. Number one, I create a vellum source, a vellum object, and a vellum solver. Let's ignore this for now. And for the vellum source, I'm connecting the moon grains, the initialization of the moon grains, and I'm going to apply a wind force, which I call big swirls, which is the swirls are larger, and another wind force where the swirls are a bit smaller. And I also have a pop drag, which increases the air resistance. It slows things down a little bit, and a pop kill. And the pop kill basically says if the position on the z-axis is less than -4, kill it. So basically if the particles go beyond -4, so it goes -4.1, 4.2, so it's less than -4, dead equals 1, which means kill the particle. And the reason I'm doing this is for performance reasons. If it just keeps going and going and going, I feel like once it reaches this point, I don't really care. It's outside of the frame of the camera, so we can just delete those particles and speed up the performance. And then we feed all this into a vellum solver, which has a few settings. Number one, I have increased the substeps. I haven't really increased anything else. Everything else is pretty much default. I think I've decreased the attraction weight. What I also have is I also bring in a SOP solver, which allows me to do some SOP level calculations inside this dot network, and I merge these two solvers into a multi-solver, making sure that the vellum is the first one. On the merge, the order is vellum solver and the SOP solver is at bottom. This is a priority thing, and I feed it into the multi-solver so it can solve both, and I output that. So what exactly is happening inside the SOP solver? In the SOP solver, I'm updating the attribute. So what I'm bringing here is okay, I brought in attribute wrangle, but I don't need this. I've actually brought in a attribute transfer, and basically I'm transferring stopped and attraction weight into the grain SOP, and I'm taking that information from the output of the WOP. So if you go back out here, remember we are initializing from here, and point WOP is ending here. So the simulation is taking this data, and then the SOP solver is taking this data and merging it in using the attribute transfer. So every frame, every subframe really, it's updating whatever is happening to the SOP solver. Which, remember, there is in the point WOP there is an animation that's updating. Okay, the stop value. So the stop as well as the attraction weight, both of these things are being animated, and this is transferring this information. Cool. And then what I do is I cache this out. So if we just take a look at the cache data, you can see this. So you can see the animation once you pass 38. Destruction starts happening here, like 45. Destruction increases somewhere here. It's like really crazy, and that's what's happening. Cool. I also add in after that a attribute wrangle. All I'm doing is I'm creating a variable, an attribute called @seed. This is the attribute seed equals 0, and then I'm saying seed equals random @ptnum. So every single one of these points has a point number. Okay, if you were to just do this or even do this, you'll see all the point numbers. Every single one has a point number, so that's a lot. You can't even see it. What I'm doing is I'm creating a random value at the seed based on the point number, so that's pretty cool. And then what I'm doing next is I'm creating a color node, and I'm changing the color type from constant to ramp from attribute. The seed attribute is just a random value from 0 to 1, and the ramp is 0 to 1. So at 0, this is the color. Somewhere here, 65% mark is a different color, and just I create a ramp that controls the color, and you can see now it kind of gives this varying gray value all over the place, which is pretty cool. If you ever use vellum grains, okay, if you use this upres sand, it does exactly this to create a sand color of the sand. So I just copy pasted that technique from here, and then I just out this for the render. Okay, I also create one last thing, which is proxy moon. And the reason I create a proxy moon is because you can, in this particular moon, it's all grains, which doesn't look so good up close. Okay, you can clearly see the grains. See, it's not so great, but this one is actual geometry, which looks a bit better, and we can use textures to make it look good. And we just combine both of these in DaVinci Resolve. Okay, so if I go here again, I'm merging in the original moon geo. I'm subdividing this to get a little bit more geometry and smooth things out a bit. I did try to output the stopped variable, but I couldn't figure out how to output this as a AOV. Once I figure that out, that would have been a better way of handling it, but it's not a big deal. We can kind of approximate in DaVinci. And then I add UVs. All I'm doing is I'm using a UV project, and I project from view, and I just project straight on from this point of view, and it kind of creates these UVs, which is roughly okay. It's just at the edges it gets a bit stretched, but it's not a big deal because no one sees the edges. I have this attribute wrangle again using the seed equals random, exactly the same thing. Copy pasted the color. I just copy pasted the previous one, and I just pasted it here to get this randomization of the color. We can just off this to show you, and then we finally output this moon proxy. And what I did then is I rendered it out from comma, and let's just go to the stage context, and here what we have is the moon sap and a camera, distant light, two distant lights. I'll tell you why we have two distant lights. One distant light gives the sunlight, and the other one just gives a fill light because this part was so dark you couldn't really see. I created a material library, and I have the moon proxy, which basically has high roughness value and a texture, a CC0 texture I got from cc0textures.com for the normal and the displacement. Both of these things add a lot of realism to the look. So just take a look if they just go to comma after I enable the materials. So you can immediately see, okay, now the moon has all these bumps and shapes. So this gives it a much more realistic look, making it look like it's an actual moon. Of course, it's a little stylized, you know, moon craters aren't so big relative to the moon, but you know, it's supposed to be a logo animation. So, and that's it. I just pretty much rendered this out. I also used the exact, I have a little bit of a camera animation going on as well, and I just animated the camera to move from here to the front, and it's just the camera being animated. So what I did was I switched this out, and I rendered a couple of frames, I think 36 frames of the proxy moon, and I rendered 210 frames of the grains destruction moon, and this basically created two renders, which I bring into DaVinci Resolve next. Alright, so now that we have the renders, it took only like 20 hours. We set everything up now in DaVinci. So here we have DaVinci Resolve. I bring in all the media tracks, and I have basically edited it out, so you can see that as I play it, as I just scrub through with the audio on mute, kind of creates the effect. It's not perfect, but it's definitely pretty cool. Okay, and then the logo kind of reveals itself. And let's now talk a little bit about how did I combine, you know, if I was to play each of these one at a time, we'll see that this is basically one render which kind of fades out and stops about here, and this one is the original grains render, which is also happening simultaneously but doesn't look as good because the grains are so visible, and that kind of dissolves at this point. So let's see how we did this. Okay, so there's a couple of things that we have to do. First of all this is fusion effects. If you don't know anything about DaVinci Resolve is pretty powerful, not because it can edit stuff, but because of its fusion capabilities, in my opinion. Okay, at the bottom we have over here the clips. So let's look at it one at a time. The first clip is basically the media in. So I'll divide my screen into two so you can see what's happening. And if I drag this here, you can see this is what the original clip looks like. And we scrub through, you can see Oh no, why is it so dark looking? Well, that's because I render out using a color space, ACES color space, and the ACES color space in a linear color space. So to fix this, we use this color space transform node. Just take ACES and linear and convert it from output ACES to sRGB. Okay, and don't ask me anything more about this. I really don't understand color spaces that well to explain in greater detail. I just figured this is how it works. Okay, then what we do is we merge it in with the stars. Okay, and the stars I created in Blender is just a really basic setup. Maybe I'll show another tutorial how I created that, but it just has simple twinkling just going on. Okay, and we merge this in this way. How do we merge it? We put the stars in the yellow pin, meaning the background, and the color space node, which is basically our moon animation, into the green section, which basically gives us this, and then this goes into the output, and that's the first slide. So this gives us the first clip. Very cool. Nothing much happening here. The real magic that's happening over here. Over here we have a couple of different setups. Okay, first we start with our moon destruction and the color space transform, so we get the correct color space. Everything's working fine here. Just look at this side, the left hand side. Then on the other side we combine it with the moon and stars. So the real magic is happening in the star section, like the background section. So basically this is the foreground and this is the background. Okay, so what's happening in the background? In the background we have the stars, which is merging in with this white background. So here you have this effect, you know, as we go through, I can fade in and out, keyframe the white background based on the stars, because in the merge section you have this thing called the blend value. You can see here I keyframed it in the beginning. It's just keep an eye on this blend value. I have this keyframed up to here to be 1, and as we go further I've keyframed it up to here to be 0.08, and as you go even further it just goes down to pretty much 0. Okay, so this blend value basically means show the white background, or basically hide the stars and show the white background, you know. Blend from 0 to 1, 1 being show the stars on top of the white background, and 0 means don't show the stars at all. In its default settings. You can blend with other settings as well to do other stuff, but that's beyond the scope of this video. Then what we do is we combine this with another merge, okay, and combine it with the logo. So we have the logo here not showing. Sorry about that. Let's just real quick, I fixed the logo. So right here we have the logo, and this is combining. So it's basically the logo with a transparent image, and this is going to combine with this set, which is basically the background stars. Okay, so this is also another merge node. I just renamed it to logo fade. And here we have another effect where you might be wondering now, how is this logo revealing all of a sudden? And this is because there's another connector to this logo fade, this merge. It's not keyframed with the blend system, okay, like the previous system. Instead we're using a mask. So this blue arrow is the mask, and we're using this. It's just a black background with a transform node, which allows me to control the effect, and this transform node is what's keyframed. If you just see what's happening little by little, we can zoom out a bit, you can see that as we go through this, the transform node is just gradually moving this black background to this side, and we're using it as a mask here. So what's happening here is, as we go through this, I have keyframed the movement of this mask, which just reveals the logo as we go through, and you can see that. Okay, and we just want to make sure it's fully revealed at this point, but I'm timing it based on what I'm seeing here, which is the destruction is happening, so I want a little bit of visibility here, and then as I go further, I know that this side is completely invisible, so I don't want to go too fast because I don't want things to be visible too early, and I just keyframe the movement of this mask node to reveal the logo. That's pretty much all that's happening here. And then I do a small transform just to increase the size of the logo a little bit and adjust the positioning, just to make sure that it is aligning with the moon's original position, just for kicks. And here we have another merge, which just merges the original destruction with this effect. So now if you look at this merge, you're merging the destruction with the background effect, and you can see here that this is moon, which looks fine, and as we go forward it destroys it. That's it. There's one last thing though. I have this proxy moon set up so that it stays here, and then it sort of fades out, destroying the moon. Okay, so this happens pretty quickly, you won't really notice it. You see that it happens so fast that you don't really notice. You just think that the moon is being destroyed. Ideally the destruction should, like, this should fade out where it's being destroyed, when it's being destroyed, but I told you I couldn't figure out how to get the AOV for the destruction mask, so I couldn't do it that way. So what I did was I just did a gradient fade kind of thing. Let's look at that. That's over here. Basically we have the original moon. I just have a single frame where it is in one position, and you can see on this side the moon is fading away. Adjust the color space as usual, and then we have a background which is basically nothing, just transparent, and this is in the foreground. And then what I do is I add an ellipse mask, and I just keyframe, okay, the size of the ellipse mask. That's it. That's all I'm doing, and I use that as a mask here, and that's it. It's just a keyframe of the ellipse mask, and that's all I'm doing here. And then once we destroy the moon, we come to the end, the logo is revealed, and as we reveal the logo, we kind of fade out the remaining dust particles. We could probably go further, but I wanted to end it fast, so we gotta fade this out. And we just have a single static image at the end, and that's the whole DaVinci setup to create this effect. And that's it, guys. I hope you like this video, and I'll catch you in the next one.